All right, so today's focus, again, we're just going to continue with our object-oriented programming discussions, kind of just get more practice with it, make sure we're getting comfortable with the idea and design concepts that we're trying to instill here. So today we're going to be talking about decorators in Python. This is kind of like a side topic, but this is important for us because we're going to be using decorators today and throughout the cohort, specifically in Django. We'll see some decorators being used. So this is a Python topic. That's kind of good to know about. And then we're going to see some use of decorators as we talk about classes. So we're going to talk about instance attributes and class attributes. Again, instance attributes we kind of got introduced to on Monday. Class attributes are very similar, but some key distinctions there. We're also going to talk about instance methods, which we covered on Monday, but then there's also class methods and static methods. So just to kind of get to know some different types of methods we could have in our classes. And then we're going to talk about more design oriented discussion about using getters and setters. We'll see why they can be beneficial. So a lot to come for this morning. But first, let's talk about decorators in Python. So decorators, again, are specific to Python, but they give us some functionality that can be really beneficial. So let's start with talking about decorators. So again, so a lot of this code is on our curriculum page in case you want to kind of reference it. Generally, we don't recommend coding along all the time. If you are up for it, you're welcome to. But again, the key focus here is make sure we focus on the concepts, and then the coding can obviously be done later. So for my decorators.py here, have some starter code. Hopefully none of this is too surprising, but I have a few functions here. I'm just going to call them my main functions. So I have an add method or add function, a subtract function, multiply and divide. And again, they're just doing our basic operations for this example. Again, you can imagine more complicated logic here if you want to, but want to keep things pretty simple, just to kind of understand decorators here. All right, and then I'm calling my functions. I call add, I call subtract, call multiply, call divide. So if we want to do some quick mental math, adding should give us 9, subtracting should give us 11, multiplying 6 and 5 should give us 30, and dividing 20 by 5 should give us 4. So if I ran this, let's do Python decorators.py. Oh, obviously I need to print some stuff out. That's not good starter code. But actually, before I print something out, let's just actually start with this. So my application ran, but actually nothing got printed out to the console. That doesn't mean that my application is not working. It's just I'm not showing anything on the display. These computations were done by my application, right? So the values I listed out, my application computed those, returned them for my functions, and that was it for the values. We compute them, return them, then we drop them because we're not saving them anywhere. So my application works, right? Hopefully you can take my word for it, but obviously we didn't print anything out to the console. Let's say our new requirements for whatever application or project we're working on is that we want to show the inputs and the outputs for every single function call that we make for our main function. So we have 4 main functions. Again, our new requirements, let's kind of just make sure we understand requirements, display the inputs and output values for our main functions. All right, so whenever I say main function, I'm referring to this group of 4 right here. So these are our new requirements. How can we achieve this so that we always output the input, or sorry, always display the input and output values for each of our functions? One way we could do this, I'm just going to do this, kind of the simplest way to achieve what we want. I'm just going to add a print statement here and say input values, input, not input, A and B. So I'm going to use string interpolation here. So again, our parameters are named A and B. So here we are going to print out A and B. We're going to take our computation and store that in a result variable. So the result will be A plus B, print our output. So output value is result. And we have arrows here to like having those. Okay, so basically I'm surrounding my computation, storing that in a variable so that I could output it, and then I need to return it. A plus B. Or sorry, this can be results. All right, so again, hopefully nothing too surprising here. We have not changed the the core functionality of our function here. We are still computing a plus b and returning it. The additional things we added per our requirements was now we're actually printing out the input and output values. All right, so if I want to kind of do this for every method, because that is what we need to do, it's going to do some copy and pasting. So this is subtract, this is multiply, and this is dividing. Okay, so we print out our inputs and outputs, and that it achieved a requirement that I kind of just made up here. Question for anyone that wants to answer. This is going to work. So let's actually see that works before we ask some questions. So Python decorators.py. Okay, notice what we get in our output or in our console here. So we get, for our add function, we got 4 and 5. The output value was 9. For our subtract function, 16 and 5, we got 11. So again, this is working. Interesting thing here, we get a floating point value for that division where we do 20 divided by 5. We could do a divide to get an int. That's going to kind of chop off any fractional component we have. So let's just leave it at floats. Okay, cool. That is exactly what we wanted. This works. Now the $1 million question is, this works. Why isn't this ideal? Anyone want to answer that for me, please?
Repeated code.
Yes, absolutely. We've, as my rule of thumb, anytime you catch yourself kind of copy and pasting a lot in your code, again, this is a very simple example. You guys have probably dealt with more intricate challenges, but anytime you catch yourself kind of repeating the same or similar code, that should kind of flash alert sign in your head saying, hey, there's probably a way to refactor this, right? We don't want to keep copying this, these lines of code, because it makes your code more bulky, right? Like now I went from whatever, maybe like 10 lines of code to now like 20, 30 lines of code. Second thing, and this is more importantly, what if we want to change our formatting, right? Like what if I want to add some exclamation marks to my inputs? So I'm really excited about my inputs. Well, since I changed it here, now I got to change it here again and change it here again. You guys understand, I'm pretty sure, why this is not the best design. It's because if something needs to be modified, now I got to do it in 4 different places, or just extrapolating it. What if I have 40 different functions or 400 functions? Again, projects can get really large. I don't want to go to every single function and modify that manually. That's just not going to be a good use of my time. And that increases the chance of bugs. So for example, let's say whatever, I had a really large project and I forgot to update my multiply function. Well, that's going to introduce some undesired behavior. And that, again, the reason this bug got introduced was because I just had 300 places to update and I accidentally forgot to update one. Right? So again, we talked about the dry principle, about the single responsibility principle, where you should have, if you're doing something, there should be ideally only one place that does that very something that you're trying to do, so that if you need to modify things, change things, you go to one single place rather than 300, 400, 500 different places in your code. So with that in mind, let's refactor this a little bit. So this works exactly how we want, but I don't want to keep adding these input output statements into every function I create. So I'm going to create a helper function. And let's call this the wrapper function. So I use the term wrapper because we're actually just going to if you imagine wrapping like a gift, we're going to wrap our functions with some additional logic. So here I'm going to create a new function and call it report IO. So IO input output. And then I'm going to pass this 3 variables or 3 parameters. One, I'm going to call main func. Second, I'm going to call A. Third, I'm going to call B. We get pretty generic. Report IO is going to do kind of the redundant work for me. So I'm going to grab what I'm trying to do here. And here is where I want to actually make my function call. So I'm actually passing a function as a parameter. So this is totally valid in Python and JavaScript and most languages. You can pass a function reference that you can call later on. So here, I know I'm going to be passing a function reference because I named my variable appropriately to clue me into the fact that this is going to store a function reference. All right, so here I could call my main function and pass it values A and B because that's what the intention of those parameters were. And now I could return the result. So given my wrapper function, I can simplify or kind of condense all my main functions here. So to use my wrapper function, I can just go back to what I had before. So if I go to return A plus B, sorry, copying pasting again, but this is useful. So you can go back to what I had before. So my functions look much simpler now. They're doing their core functionality, which is the computation I wanted. The other stuff is centralized in my report IO function. Now, how can I use my report IO function to get the desired requirement that I said before? Well, now we have this wrapper function. And again, the reason I use the term wrapper is because I'm basically surrounding my function call right here with some additional logic. So I have, printing out the inputs and the outputs. Okay, so if I wanted to actually achieve what I was doing before, I could surround, or actually use my report IO, pass it my function name. So in this case, add is my function, and the values I want to pass to add eventually, because that's what's being done right here, right? So if I pass in add, which is a function reference, and the values I wanted to use in add, I can use this within my wrapper function to actually call add or subtract or whatever function I specified with the appropriate parameters. So I'm just going to do that for my 3 calls here, reports IO. Again, as always, if there's any questions to what I'm trying to do here, please stop me because I don't want to lose anyone. But again, just keep calling my wrapper function that will do the logic that I want for every function call and make the function call for me. So report IO and divide. Okay, so there we go. Why is that squiggling at me? Oh, I mistyped it. All right, so now, again, I'm calling report IO, which will eventually call my main function for me. The question is, have we met our requirements? So here, again, this is what we expect to see for our output. Again, with my refactor, let's run this code again. So we're gonna do Python decorators.py. Notice we get the same output. Yes, I added those exclamation marks, I guess, because I'm really excited about my inputs. But this is what we want, right? It's the same general output, but we have more condensed code. So now, again, if we need to change, if our requirements change, whatever, for our output, like let's say we want to, put $signs here, great. We only change it in one single place and not 4 or 400 different places. So again, the concept of the dry principle, don't repeat yourself, that's what we're seeing here, where instead of repeating ourselves over and over in our main functions, we centralize it and have a single place that does our key piece of functionality. What questions do you guys have about this refactoring or the dry principle or anything that maybe you're confused about? Porfi?
Yeah, thank you. How deep can you go on like this, like Russian doll kind of paradigm where you're just like housing functions inside of functions to reference the functions?
I mean, the world is your oyster. So you can call a function within a function. I could have a new function that maybe, new function here that, if I can type correctly, that could take the return value of this call. So again, you can nest functions within functions, and then other function might take that. So you can nest functions, call them directly. So in this case, I'm calling report IO. Whatever that returns, I'm going to pass that return value new function, which is going to be passed to the other function here. Yeah, you can nest as much as you want. However, I would argue this becomes poor coding style. If you have like 7 nested functions, that's going to be kind of hard to read. So I would always break this up into like, return, or call it results equals, whatever I got from back from my report IO, and then I would pass that into my next function just to make it easier to understand. But technically speaking, you can nest as many functions as you want. Cool. Thanks for that question. Any other questions out there? I see 2 hand raised, so go for it. Jin, go for it.
So this is what you'd call the decorator? Right?
Not yet. So we're getting to decorators.
Oh, okay.
But we're kind of just like showing how we approach how decorators kind of give us functionality. So yeah, let's kind of move on and see what decorators actually are in Python. So again, this is specific to Python. Nathan, you have a question?
Yeah, it's more on the output. Why didn't the dollar signs print? Are those like a special operator in Python?
Oh, no, sorry for that confusion. I kind of add these in after I print this stuff out.
Oh,
Yeah, I was just saying if we needed to change something, so I could run this with dollar signs. I always like to see some dollar signs.
my mistake. Got it.
Yep, no, sorry for confusing you, but yeah, I was just saying if we need to change anything, we change it in one place. In this case, I just added dollar signs just for fun. Okay, so let's continue on and kind of see how we arrive at a decorator. So this works, right? This gives us what we want, but we changed a little bit of functionality here. Okay, so originally where we had all the print statements in each of our methods, I'm not sure why these are tabbed out weirdly. We forced every function call to print the input and output values. That's our requirements. So let's say we must display. So this should not be optional. Like whatever our silly application is doing, our requirement says we have to display the input and outputs. So with our current design, we are able to achieve that, but we actually introduced some different functionality. So let's say I wrote this piece of code and I handed it off to Joseph. Well, Joseph can use my code, and if he's using it properly, he's always going to use report IO. But there's nothing stopping Joseph from actually just calling add 7 and 14. He can still call this method, and if he calls it in this manner, our input and output are not going to be displayed, right? So if I actually ran this, our output's going to look the same, right? We have our original values from these 4 function calls, but we still are doing an add operation here with 7 and 14. That's not shown in my display, and this is going against our requirements in this case, because our requirement said we have to every single time show our input and outputs. So while we did kind of condense our code and improved it by, again, having a single responsibility function here, we improved our code, but we also changed slightly what our code was doing. So the question is, well, how can we still have clean condensed code, but also enforce that we print out the inputs and outputs? And this is the one solution for this is using decorators in Python. Again, there are other solutions you maybe come up with, but decorators are kind of simple and nice and easy to use. And they're kind of, again, keep your code kind of uncluttered. So to create a decorator, I'm actually going to use my wrapper function and change a few things about it so that I could use it as a decorator. And I know I'm using the term decorator a lot. We're going to see it in play. So if you're still kind of wondering, like, what is decorator? We're going to find out right now. So here, I have a wrapper function. This is doing the central piece of logic where I want to do something before and maybe after my function call. So I'm going to change a couple things about report IO. I'm going to add another nested function. I'm not sure if we've done this before, but this is totally valid. We can create functions within functions. So here I'm going to call this wrapper func, just for lack of a better name. And here I'm going to take in A and B. This will take in nothing. All right, so we got maybe some unfamiliar things going on here. But first thing I want to point out is you can create a function within the function. This is the same idea as if I create a variable called x and assign that to 9 and then just return 9. Oops, return x. So here I create a variable and I return it. Same thing going on here. Instead, we create a function and we just return that function reference. Again, we're not calling the function here. I should probably get rid of this code because it's graying out the rest of my code. But we're just basically creating something in our function and returning it out of our function. All right, again, to be clear, I'm not calling my function here. I'm just returning a reference so that we can call this function at a later time. And that's something our decorators can do for us automatically. So this wrapper function contains our shared logic and also calls our function. Should probably take the main function. So I want to make sure I have my syntax correct. So yeah, so here we're converting this. Oh, so main function should be there. Does that make sense? So main function is still going to be a parameter to my report IO, and then the parameters will go down here. Sorry for that. So again, main function is the function that you are wrapping with your decorator, and then your wrapper function is what's going to do all the shared logic. In this case, putting in the input outputs and calling our main function. I'm just going to pause here. Again, if there's any unfamiliarity with the syntax here, please do ask, because I don't want to lose anyone with this. But again, create an inner function. Notice that we have a parameter to report IO. That is still accessible inside this nested function, right? The same principles as we talked about before, where I create x equals 9, then I have an if statement. If y equals 10, if x is less than y, x equals 8. I don't know. But same principles where I create a variable on the outside and it's still available inside, like in an inner block here. So same thing, we have main function out here. It's accessible inside this inner function that we create. Andrew, question.
Yeah, when you put in main function there, you still have to give it values for A and B, right?
Right here?
Yes.
No, so this is where decorators kind of have some magic behind the scenes, but we're just passing the function that needs to be wrapped with this decorator, and then the wrapper function will take in the inputs. So I know it's like the question I think, Andrew, you're leading to is, well, how are A and B actually being passed into report IO? And we'll see that with our decorator. Jin, you have a question?
Oh, no, sorry, I didn't.
Okay. So we're returning our wrapper function reference. So again, we're not calling our wrapper function here, we're just returning it. This is the structure for creating a decorator. We're creating a manual decorator here. Again, Python has a few built-in decorators that we're gonna see and maybe use, but we're creating our own decorator here. But you need to follow this format. You have an outer function that takes in the the main function that you want to call, and then you have a wrapper function that does your functionality. In this case, we're printing before and after our main function call. So that's what the wrapper function is responsible for. All right, so with this in place, Sukhdev, you have a question?
Yes, thank you. I was just curious, what is the difference between a wrapper function and helper function, just in terms of terminology?
Good question. I assume there might be official definitions, so I was going to give you my definition. A helper function is just like a buddy on the side that's going to do some work for you. A wrapper function is something that's actually encompassing your function. So again, the visual that I give is wrapping a present. Imagine that the present that you have is your main function. The wrapper is going to add stuff kind of around it, meaning you can do stuff before and or after your main function call. So it's actually wrapping our main function call with additional functionality. In this case, printing out some values. But a helper function, again, a helper might be, let's say I want to negate these values. I can call negates values function. And in this case, I would call negate values a helper function, because I could do that, right here, where I just multiply this by -1. But if I have a separate kind of additional buddy that I can call, I would call that a helper function. I don't know if that distinction is clear enough. Again, those are kind of my definitions, but that is the terminology there. Rob, you have a question?
Yeah, so if you were to add like a fifth main function that say had actually 3 parameters being passed in, so like a plus b and then divided by c, would you still be able to use the wrapper function, or would that break it now because you're only expecting 2 parameters?
Excellent question. The answer is yes, this is possible, but no, it's not possible with what we've coded here. So I'm gonna say yes, but let's wait. So I think the suggestion was a plus b and then divided by c. Yep, totally possible with decorators, but I'm going to table this right now, but thank you for bringing that up. So currently we are hard coding that this decorator function can only be used with a main function that accepts 2 parameters, right? Because we're calling main function with exactly 2 parameters. This is Python, not JavaScript, so we can't add more or add fewer. We must call it with two values. Well, let's actually see how we use this decorator. So now we have report IO. We've structured it as a decorator. So again, we are returning a function reference. That is the key change we made between our previous implementation of our wrapper function and our new implementation. Now to use our decorator, we're going to use the @ symbol and then the name of our decorator, report.io. So I'm going to pass or add this. Basically, you're tagging each function at the very top. Oops. So yes, I mean, I am copy and pasting, but that is okay because I'm just calling the same function here. So what's going on here? Report.io, I've created a decorator to actually use decorator, use the @ symbol. So using our custom decorator, @ symbol plus decorator name. All right, so this syntax in Python is saying, all right, you have a decorator function. You told me it's a decorator with this @ symbol. I'm going to pass this function into report.io. Right, so I've basically wrapped what I've highlighted right now with report.io in a similar manner where we're doing right here, where we call report.io ourselves with our previous implementation. Now we're just saying this function is wrapped by report.io. So what's going to happen with Python here, the way decorators are used, my add function is going to be passed as the main function. That is the parameter that report.io is going to take in. And then my A and B, I still need to kind of pass in here. So our function calls here go back to what we had before. So I'm just going to change that to what we had before and then talk about what's actually going on here. Jake, you have a question?
I think you might be about to answer it. I was going to say, does that @report.io, that little decorator label, does that prevent you from being able to call these functions like add, divide, all that without invoking the report.io function?
Yep, great question. So now I've actually changed this back to what I had like at the very beginning, right? Where I just had, simply the calculations and I just wanted to call those functions. But now we call these functions normally. So I'm calling add 54. But what's going to happen is when I make this function call, report.io is going to kind of intercept it and say, okay, well, I'm actually wrapping the add function. So let me do this stuff for you automatically. So this is, again, this is going to require, or this is going to mandate that the input and output are going to be called. There's no option to the developer. So again, halfway through our change here, we improved our code, but we added some undesired functionality where we can kind of get around printing the input and output values. But the way we've designed with decorators now, there's no way around it. I'm calling add just like I did before. Report.io is going to intercept that call and say, okay, well, we need to do a few things before and after that main function call. So yep, our calls become easier. Like again, me as a user of my, or let's say I created this and then I hand it to Andrew. Andrew does not need to know what's required for add. He's just going to use my function as if, he expects it to add 4 and 5. That's all he's going to care about. But our requirements were we need to print input and output. So it's going to be done automatically. There's no way around Andrew, or Andrew can't get around that fact. He's got to work with what I've designed here. So if I run this now, let's make sure we get the desired functionality. So if I run Python decorators.py, notice we get the same output we were getting before, or the same displayed items. Again, what's going on here is we call add 4 and 5. Report.io says, okay, you're calling the add function. I'm going to pass that to our decorator. So this is the value of add, or function reference. And the wrapper function gets actually called with the parameters passed here. So again, I know it's kind of hard to take in. You're like, there's a lot of magic going on. This is what decorators are just kind of designed to do in Python. So whatever parameters you actually call here, so I've called 4 and 5, that's going to be passed to my wrapper function here. So 4 and 5 will come in here, and then it's going to do this logic, kind of like before with our wrapper function. Elin?
Just a very basic question. So for the naming, the report.io and the wrapper function, are those just the names for this specific example? And we can use whatever we want as long as we follow this framework.
Absolutely. Yep.
Okay.
Well put. Yeah. So I'm using wrapper func as just a variable, as a function variable name. Main func again is just a variable name, and report.io is the name I gave for my wrapper function. this again, you can use any standard naming convention that you want for yourself. The important thing is when you use your wrapper, you just use the @ symbol and then whatever you name your wrapper, or sorry, your decorator function. Marcos?
So, like, where would you use this in a real life example?
I mean, I would argue this is a real life example in the sense where I had functionality that I had to mandate, and I achieved that by using a decorator. I guess if you want like a more real world, one way we will see this when we're using Django is, let's say we create a website, and to get to certain pages, like if I want to get to my account details page, I need to be logged in first. Like I shouldn't be able to just log in or go to any website like Amazon.com and see Marcos's account information. I need to log in first. If I don't log in, a lot of websites will redirect you and say, hey, wait, you gotta log in first. So one use of decorators would be, you might have a function that gives you a view. So the view might be your shopping cart or your account page. You're gonna wrap that with a decorator called, maybe like login is required in order to access this page. So what your decorator logic would do would be like, we'll check, hey, is this person logged in? If the answer is yes, cool, proceed to show the web page. If they're not logged in, maybe redirect them to a login page. So again, that's something you're gonna wanna do for multiple pages. So instead of, again, rewriting that code over and over again, you would just create a decorator that's gonna always check for whatever web pages require login functionality. Lyman?
Yes, so for the decorator function, is the reason you do a nested function because you can't add additional parameters to the main function because you're using it as a decorator? Like why are you doing a nested function within this function?
Yeah, so the reason we have a nested function is because the decorator is going to call this function for us.
Okay.
So
got it. Okay.
A and B,
got it.
what we
Okay.
pass to our original function, that is what is going to do the rest of the logic for us.
So what would happen if you didn't do that? I'm just out of curiosity. So what would be, so if you didn't do this nested function, what would happen if you just put the logic inside and just report IO function? How would it
it's a great,
if you did that.
Yep. So this is kind of what our wrapper function looked like before. That's actually what happened. So I'm gonna anticipate Python's gonna yell at me. Yeah. So it's, again, decorators require very specific syntax. So right now I'm trying to use this non-decorator function as a decorator, and Python's like, well, I don't know what you're trying to do here. Yeah, good.
That makes sense.
Always worth trying. Marcin?
Can the decorator function take like arguments of its own? So could you have like decorator, so like report IO +1 for whatever reason, or +X? So then it would report the IO plus whatever argument you give the decorator. Can you do that?
Yes, it is possible. So we're getting to a few more advanced uses of decorators. So we just want to give like an introduction. So there were, I will get to that just to kind of show it, but I don't want to lose too much of the audience because again, decorators, we're still kind of new to them. Again, I just want to give you the idea of the concept of you can create your own decorators, kind of achieve repeated logic and enforce like certain behaviors that you want to be done for certain function calls or whatever you might be doing. The couple advanced questions, and I'm happy to go over them. So I'm just gonna go over them briefly. Don't want to spend too much time on them, but one question that was asked was, what if I want to pass 3 arguments, right? Like what if we had an add and divide function that takes in A, B, and C? How do we do that? Well, if you try to do that right now and use the decorator here, report IO, what's gonna happen, right? So let's call add and divide. Let's keep our numbers simple. So let's go 2 + 3, and then divide it by 5. Let's change that up. Let's go 4 + 6 divided by 5 should give us 2. Let's try to run this and see what happens. Notice we get an error, and this is the error we would expect. It says wrapper function only takes 2 arguments, but you gave us 3. Yeah, so the reason is because we didn't make our wrapper function flexible. This goes back to Python function design. Again, the syntax here might look a little weird. I think you might have seen this before. Raphael might have covered this, but you want to make this args and quargs. So this is a, if I could spell this correctly. Now this is a kind of a flexible function that can take any number of arguments or keyword arguments into them. So this is going to be a list and a dictionary, I believe. So using this format, you can pass any number of arguments and this should still work. So here, instead of passing A and B, I'm going to pass args and quarks. So I'm basically just forwarding everything that was passed here. Main function will now take any number of arguments or any number of keyword arguments. Let's say I want to still print out all my input. I'm going to get a little more advanced here. Hopefully you guys can bear with me. I'm going to use a list comprehension. I'm going to do for arg for arg and args dot join maybe and. All right, so this is again a little more advanced, but this list comprehension is basically going to iterate over my argument list, give me each individual argument, going to create a list out of that, and I'm going to do a join on that. In fact, actually, if I can just do a join on args, let me just see this. That's a tuple, not a list. All right, fair enough. All right, so I'm going to try doing it this way. Let me just do it this way. Okay.
Could you put the tuple inside of a list? Just put like list with the data in it. Would that work?
That's a great suggestion. Join. I think that should work. Let's see.
If not, you could maybe even use the set method too, I think. If I'm not mistaken.
Don't you have to put don't you have to put join on the front?
Yeah, sorry, let me quickly look this up. So join Python list.
Gotta love it switching between Python and JavaScript.
Yeah, I do that often. So join, join. This doesn't even tell me about join. Python list to string join. It looks like string dot join. That's what I want. Okay, so that's what I want, I think. List of string, yeah. So sorry about that. Python and JavaScript. So join and then list and arg. Is that what I want?
Yeah, and then you put and in there instead. So if you want to make it say and.
All right, it's not liking the syntax. Oh, single quotes. Sorry, this became more complicated than I wanted, but all right, it's liking that. So again, here I'm just taking any number of arguments and kind of making that into a string. Let's see if this works kind of like I wanted, but I don't want to spend too much time on this particular issue. Expected string instance. All right, I'm just gonna go back to my list comprehension, because sorry. Parts. I'm just gonna have it do this. It's gonna be slightly different than what we had originally, but apologies for kind of punting on this issue. We run this. Now we are able to call, any number of parameters. So here we're calling add and divide. Notice we get the input values and the output value for that function. So again, this gives us flexibility. So we could add any number of arguments. We could be one argument, could be 73 arguments. This structure or this syntax in Python gives you that flexibility. So that answers the question of, can we have functions that take in a variable number of parameters, not always two? The answer is yes. Again, we're getting a little more advanced with decorators here. So if you're kind of like, I'm still really weirded out by decorators, don't worry too much about this. We're not going to use this right today. I just want to introduce the fact that we can do it. I think the other question was, can you pass a parameter to a decorator? The answer is yes, but it gets a little more murky. You're going to actually have 3 levels of decorators or of functions, I believe. So again, I haven't done this in a while, so apologies, but I think you do something like this where, so now your decorator can actually take in an argument. I think that's how you do it, but it's giving me some weird, I call it outer function. So let's call this deco with param. I think this should work. Again, I'm gonna try this. If it doesn't work, then I'm gonna punt on it because we have other things to get to, but I think this is the format from my recollection. So we created, again, 3 levels of functions. It gets kind of weird. We have this outer function, this inner function, and then another inner function. So this is what I had before. I kind of just wrapped it with another function that takes in any value that we want. So now I'm passing 2 as a value so that I can add that value to whatever result I get. So let's actually see if this works. I'm not even sure, but let me just call one function here. So if I call add 4 and 5, it's going to call deco with param with 2. So what that should do is add a plus b, which is 4 plus 5, give us 9. And additionally, we're going to tack on a value of 2 because that is what our decorator parameter specified. So it gives us some flexibility with decorators. So let's see if this actually works. If it blows up in my face, who knows? Okay, there we go. So notice that the output is 11 because we said our decorator is going to always prefix a value of 2. And then we're going to still do the same logic we're doing before. Again, I know this doesn't make much sense. Like, why are we doing it this way? But yes, we could have something more complicated, like, you know, we could pass another function that says, if this is negative, you know, throw an error or something. So here I could say check neg function and then pass that as here. Again, this is probably getting way too complicated, but so create another function. This I would actually call a helper function. Def is neg, taking a value, and then let's say print if value is less than 0, print something else. All right, so now we are going to pass in a function here. Now let's say we only want to do that for our addition case and not for our subtract case, or maybe it makes more sense to do it for subtract because we get negative numbers that way more easily probably. So let's say our negative function wants to check if it's going to be negative and print it out. Our addition doesn't care. So this can be a none value. You guys following me? I know I'm probably losing some of you guys, but this will be the last thing I do for decorators. So now we are passing a parameter or passing none. So is neg is going to be a function that we can call. So let's say if check neg function is not none, let's say is not none, then call our check neg function with our results. All right, so this is maybe a more applicable usage of where we pass a value into our decorator. So I pass is neg, which is going to print out OMG, this value is negative if we get a negative value. So let's do a couple examples and then we'll call it a day. So if I have subtract 16 and 5, that should not trigger that negative check. But if we have 1 and 5, that should give us -4. So let's run this and see what happens. All right, there we go. So we got, oh my God, this value is negative because we got -4. Okay, I know that might have confused, a lot of you guys. I don't want to focus too much on decorators because we have more class OOP stuff, specific stuff to do. But the main takeaway here is that decorators exist in Python. There's some built-in decorators. You can create your own to kind of make your code more elegant and compact. All right, so let's pause there. Yelin, you have a question?
Just another really basic question. I'm not sure if you already went over this. So what if like the user just want to get a basic functionality from the function, say just return a number instead of the entire like the context?
Sorry, I'm not sure what you're asking there.
Like say if you pass the function add with all the script, it probably will return, like it will print all the script along with the a plus b answer. Like what if the user just want the number, the a plus b, without all the...
Well, that's the thing. per my requirements, I am preventing that. If you want to use my
Okay.
add function, again, our requirement says we have to get the input or output. This is our design choice. If we want to make it optional, we could explore some of the other options where we had like a report IO just wrapper function that could optionally be added to our function calls. But in this case, since I just said for this, our education purposes, this is a requirement. How do we achieve that? You can achieve it with a wrapper.
Okay, thank you.
Brandon?
Yeah, so how much of using decorator functions is creating your own versus using built-in decorators in like frameworks such as Django?
Yeah, I would say most of the time, in my experience, you're just going to be using built-in decorators. Very rarely will you have a real reason to create your own decorator, but the idea here is you can do it if you need to. But yeah, we're not going to be doing it too much. So again, I don't want to focus too much on decorators. I want to give a basic understanding of what decorators are in Python. And to simplify it, the last takeaway, decorators basically allow you to wrap function behavior so that you can do something before or after your function call. That is essentially what our decorator is doing. Again, you could achieve this without decorators, but in Python, decorators are kind of simpler to use once you get familiar with them. Okay, so that was probably a lot to take in, and we still haven't talked about OOP. So let's actually get to OOP discussion after we take a short break. So it's 11 o'clock on the nose right now. Let's take a good 10-minute break, and we're going to get back to our OOP focused discussions.